Our next test moving into the oculomotor examination is saccade testing. And what we can see here with saccade testing is we have random eye movements being generated that are quick and can move both horizontally and vertically. And we can track the eyes moving for each of these random steps. To quantify saccade testing, we need to carry out approximately 20 saccades in each direction to fully utilize the pattern or changes that may be present. These measurements can be indicated as follows. What we can see here is a step change where the eyes have moved from a left position across primary into the right position, and they track the target and follow the target back once again. Now within this test we've got some different parameters that we can look at that allow us to quantify some of the abnormalities. So I'd like you to have a little look at our first abnormality here. What we have is an eye movement, and what we're measuring is a latency of eye movement. So the time that it takes for the eye to move after the target has initiated the eye movement. Now, typically what we would see are eye movements around about 100 to 120 milliseconds following the target movement. Any delay in this movement of greater than 200 milliseconds, if it is a consistent pattern and follows through the saccades, we can look at whether that eye movement is delayed both unilaterally, either to the right or to the left, or up or down for vertical saccades, or whether it's bidirectional and that it's present in either the horizontal or the vertical plane. Abnormalities within the latency of movement are often described within the central nervous system structures as being frontal or frontoparietal cortex, or even within the basal ganglia. We can come back to some of these abnormalities further into the presentation. Our next parameter to look at within the saccade test is velocity. So how fast does the eye move after being initiated following the target? Again, we can look at normal data, both for age, gender, and we can have a look at whether a delay in this eye movement, again, is present either in a unilateral or bilateral directions, again, horizontal or vertical. And delays within velocity give us some indication within the central nervous system of looking at structures such as the supranuclear complex, the brainstem, again, basal ganglia, and are often associated with more neurodegenerative diseases such as Parkinson's or Huntington's or progressive supranuclear palsy, and even spinal cerebellar degeneration. Our other parameter to look at within a saccade test is accuracy. Now this is calculated as the percentage of distance that the eye is often moved following the first target movement. If the eye moves to the same distance as the target has moved, then this is 100% of movement. But we can then start to quantify that movement both as a percentage and its nature. So we may have a movement that doesn't fully reach the same point as the target, and that we would describe as hypermetria. And again, these could be lesions that are affecting the cerebellar flocculus or the dorsal vermis. Or we may have a movement that's actually exceeded the target movement, and then a correction has been placed back on the target. And again, these would be more consistent with lesions within the cerebellum. An example of an impairment to the saccade test, we can look at internuclear ophthalmoplegia, and that can have palsies both in a unilateral or bilateral direction, where the eye ducts inappropriately, creating either doubling of vision in the horizontal plane and dizziness and unsteadiness if the patient is stood.